Como decíamos, buenas tardes, bienvenidos a esta segunda jornada en la que nos encontramos celebrando la designación del Centro de Excelencia sobre Innovación y Tecnologías Transformadoras en Economía Circular como centro
in transformative technologies. Let us begin by introducing the experts on circular economy. First, official senior head of the climate change section, Department of Sustainable Development from the Organization of American States, Mr. Ruben Contreras. Good afternoon. Hope you enjoyed your lunch. We had great wine and meat. Due to time constraints, I'll try to be brief. With Raquel, we want to give you an overview about the OAS. It's always good to talk a little about it and then tell you about our ambitions as a regional agency to support circular economy in the hemisphere and for the regions. The Organization of American States is a regional entity that focuses mainly, you can see it on the screen, there are four main pillars. The most important one is development, which is our approach. Our focus is democracy, human rights, and security. Without support, we cannot really meet these goals. I mean, we cannot have human rights without the support of the other pillars. So we have the Secretariat of Human Rights, and our added value is to support member states to improve their socioeconomic aspects in an inclusive way. And these are the pillars we work on. I come from the Sustainable Development Department, but there is economic development, human development, education, employment, political dialogue, technical cooperation, and the Inter-American Commission of Ports. So you can see that our scope is quite comprehensive, holistic, and it's not just about a particular set of actions. And the other thing is that the work in SETI is quite cross-sectional. For example, in my case, we support other departments to address these issues. Just to give you an idea about our department, the Department of Sustainable Development, basically the main topic, the main issue addressed is to look at the priorities countries have in terms of the 2030 development agenda. And in terms of mandates, I mean, what drives us to do things? First of all, we get the inputs from the countries, and then last year in October, we had a ministerial meeting where we agreed on the work to be done in the region, the action plan, climate change in the first place, and the date of implementation 2023-2030. And as you can see in more detail, water resources, energy transition, climate change, and disaster and risk management. Now you have an overview, quite now I'll talk about the importance of circular economy and the connection with technology and sustainable development. First, something that is relevant is population landmarking. 80% of the population live in cities. 80%. This means that outside of the big cities, out of Buenos Aires, 20% of the people live in the rest of the areas. And on the other hand, if you look at the chart, you can see Why is this graph important? Because the population grew exponentially. In less than 200 years, we got to 8 billion people in the world. In Latin America, over here, you can see the population density, except for the Amazon. We have less space in the square, in the region of square meters in the southern corn. But in general, we can see that, the quantity of resources and services that this quantity of population demands is difficult to meet. So because energy, infrastructure required, and we have an energy system that is based on fossil fuels, which connects to climate change and environmental issues. This leads to lower or less equality. And after the pandemics in Latin America, in our region, there are 300 million poor people, and this increased a lot after the pandemics. So the region lost development in less than a decade. In 2 years, that was during the pandemics, we lost about 10 years of development. So in terms of development and finances, this is a very big impact. And since we don't have the capacity to meet the demands of over the quantity of population in the region, there is increasing demand, and it is very difficult to address this demand. If we look at energy, why or how does circular economy connect with renewable energies? Because we want to have products that result from circular economy to have a low emissions, low pollution, and we want to use land in a more friendly way. If you look at this curve, the curve accounts for the oil production versus oil reserves. And in 2050, world reserves will drop, and the only option will be to use oil from the poles, particularly the Arctic areas. And the sources of other fossil fuels, such as gas, for example, once they are depleted, then they cannot regenerate. This is why it's important to use energies that can be considered infinite. And the other connection with circular economy is that renewable energies are low entropic because they are less chaotic. What do I mean by this? And we can usually, I talk about the wired headphones. When you wrap them and put them in your pocket. When you remove from the pocket, it was all tangled up. This is the chaos. So these fossil fuels, as they degrade a material and the material is burned, which is a very primitive way to create energy, that creates more entropy and has a bigger impact on the environment. For example, ocean acidification, temperature changes, and we're changing the geochemistry of the planet. The other issue is that Latin America does not control oil and gas markets, so volatility of prices is out of the control of Argentina and Brazil. That is, we don't have decision-making power in terms of price. And every time there's a price increase, if you take a look at the gray areas, when there's a price rise, then because some economic crisis took place worldwide, like in the 80s, and then there's a green line that you can look at the presentation. The green line represents the Ukraine-Russia war that impacts on the oil of price and the cost of all of the sectors, that is the transportation, agriculture, services, everything, because everything requires transportation. So this is why circular economy drives and promotes the use of renewable resources. And another piece of information is related to renewable energies and why it's important to produce things locally, not globally. Another thing is the paradigm shift. This is the linear type of economy that we've been talking about. By removing resources, then we manufacture things, and then we just waste it, we just dispose of it. None of the things that we produce these days is devised in a way to be reused, not even once. And in fact, this is the biggest challenge. I mean, given the conditions of our products, what is feasible to do is to recycle. But to speak of a recycling process based on circular economy, we call it super recycling because it's above recycling. Recycling is just recovering whatever it can be recovered out of millions of tons of waste, but super recycling is what we consider waste. We can reuse it and add value to this waste in new products. A clear example is photovoltaic energy that is devised to generate a benefit, but we never thought about the life of photovoltaic panels. So we'll have millions of tons of these photovoltaic panels, and if you just dump them in a landfill, then it's useless. So all of the investment is going to be lost. So this is just an issue. I mean, there are millions of them, like cell phones, like computers. I mean, all of these devices are in the same category, and you may have heard this, and Raquel will talk about is redesign. Why? Because waste that we generate, it is about how things are designed. I mean, we design something to address a problem, but we never think about what's going to happen once the problem is solved. And the clear example is, if we just look at nature, nature should inspire us, inspire people who are, in design. This is just an example, right? When fruit drop, it's not actually waste. This feeds bees. It's a fertilizer for the soil. It creates steam, liquids, and organic matter that also helps regulate the cycle in the soil, enriching the soil. This is just an example. There are millions of them. And every time you look at nature, it's not only reusable, but it's good for the rest of the parties that are involved in the cycle. For example, it's not like the engine fails and you just throw it away. And waste has a double impact: pollution and the visual pollution too, right? Because having piles of waste, also odors. So there are several impacts we have not thought about that, we'll have issues with landfills and so on and so forth. So the implications go from energy, access to material, because once you have the capacity to generate regulations where you're going to demand, for example, a cooler coming from or a fridge coming from China, you will require different specifications. And for example, the metal parts, they can be reused for the local industries. Then this is related to what I said before. Why is it good to focus on circular economy? And basically, the most important thing is that it complies with the three principles of sustainable development: environmental benefits, social benefits, and economic benefits. And I believe this is the key, right? I mean, When I go to meetings and I talk to the private sector, it's the weather, it's the air, it's going to be a problem to generate change in their industry. But if I say that there's a business opportunity to access new markets, to add value, or to control the material flow, the whole perspective changes if I can prove, if I can show them about their possible benefits. So at an initial stage, as the new generations learn, and we as the older generations continue creating awareness on these issues, I believe that it's something important is to talk about this economics perspective. It's not just a challenge, how to avoid this, how to prevent pollution. It's a business at the end of the path. And the business has a structure, and the structure is to think about we're going to produce is not waste once the life cycle ends. It's actually food for another process, and by using renewable energies in the medium and long term, it's going to be cheaper than using conventional energies. And then the other hand is creating social responsibility, because both the community and the business community and the civil society will change the way they see the environment and the interaction with the environment and the products. So you begin to question, the structure of the products, whether, for example, this remote control is made of plastic or wood. And so the corrective action that is taken, which is the start actually, it's not that we can change the industry overnight. We have to start with something, and the first step is a corrective action of the waste we have today, what can be reused, where we can add value, and this is what you're doing really, really great here. So congratulations on what you're doing, because you have teams of designers that are really looking ahead. So in the linear system, what is promoted is reusing, reducing, and then recycling. Once we have the capacity, the political capacity, because politics is part of the process, to have regulations, for example, for imports, as Europe, for example, is doing, they began to demand companies they should have circularity index, so that states how much the product can be recycled, that products are easy to disassemble, and the other thing is redesigning the material. For example, photovoltaic panels, because it's something that I was pretty much involved in. They have a housing, an acrylic housing, and the only way to break it is by using pyrolysis. And pyrolysis is the amount of energy that is required to melt it, is even higher than the energy that is required to build the panel. So it's pointless. And the other thing is by using acid, which is highly corrosive, and we're going to drop it in a river, landfill, and continue polluting. So the redesign and selecting a different kind of material that is easier to reuse or to remove. And next is supra recycling, which is recycling but in a circular economy system. Reducing, reusing, and I think that Latin America, we have this culture, like if your TV breaks down, you fix it, you have it fixed. And the landfills, that would be the last resource. When the product has been reused for many, many times, you cannot add more value, and you don't have alternative materials, then you can dump it. So in circular economy, I like the cradle to cradle, to speak about the cradle to cradle concept, which is to segregate two cycles, the biological and the technical cycles. The biological cycle, for example, if I manufacture a garment using some cotton or different kind of natural fibers, then if the garment cannot be sold, you can, dump it and it can be used as a fertilizer. Design is key because the impact it would have, when it's dumped, the impact was studied. So when something is designed, it must be sustainable. And then the technical has to do with the technical flow of the materials. So here, the smart design, having materials with high usability, efficiency, non-toxicity, these are key issues in circular economy. I have 3 more slides. These are the challenges that I see at a large scale. This is, broadly speaking, to generate policies, agreements. First of all, the energy limitation. That is, if you have a product or material or a product that has a material that has been highly mixed, randomly. For example, a plastic that used 10 different kinds of plastic to be manufactured. To try to segregate that, you would need a lot of energy. So we have an energetic limitation. So you want to have, practical materials that can be segregated once the product reaches its life span. And then scales is not the same reusing a product such as newspaper, paper that has been is used for a couple of days, and compared to a photovoltaic panel that is going to be seated for 30 years or so. So the recovery of materials. This is why we say that the best pilot actions that can be taken for circular economy are at a local stage with products that have a shorter life, a couple of years, months, or days, so that you can see how the material flows and you can better understand whether you can develop the structure that is required to understand the challenges that are involved in the process. And the other important thing, and I think that Argentina has comparatively less than the other Latin American countries, is primary economies. We just remove and sell, materials, vegetables, and we sell them. And that is, there are very few countries that manufacture vehicles, or so countries that don't have technology industries. They will not have, like places where they can actually recycle, their products. For example, the United States, with the case of glass, it was not part of their own process, so they sent glass to be recycled to China. So it's important to have, and this is the other issue, infrastructure. You need to have industrial capacity in order to recover the material. Otherwise, the other option would be to sell it. But who are you going to sell it to? And the other thing is to create regional standards, because if you want to sell your circular economy products, the other person will have to accept them as such. Why is it circular? So you need to have a standardization, some sort of certification system. This is important as an organization for us to open up this dialogue, to create these regulations, these policies. And then the academia has to develop theoretical models for material flows, thermodynamic limitations, and databases. If you want to use blockchain and artificial intelligence, we need better data and data classification and analysis in order to understand the impact on the environment and the impact on our health. This is just an overview of the industrial flow. The industrial flow, the biological aspect is not included. And let me conclude by saying, but by talking about what we want from the OAS and what we want to support. First of all, the promotion, improvement of circular economy policies to harmonize regional integration. So we'll need here national leaders, such as the case of Córdoba, so that other cities and countries can learn what can be done. Then to continue developing capacities and exchanging knowledge. Now we have other centers of excellence learning what is being done here and how we can, for example, connect blockchain or artificial intelligence with what you're doing here. Then public-private partnerships, innovation, technology transfer, and then projects, how to get donors, investments, to work with allies, strategic partners to improve circular economy governance and to organize resources. This is just an example. We were the leaders in Latin America to support a company, a small, very small company in Ecuador, to certify their packaging. The cereal bar has a cradle-to-cradle certification. The packaging was biodegradable with organic ink, and with this, they were able to get into the Dutch market. I mean, if you fly, for example, a Dutch airliner, you can actually eat their bar. This is just an example, but with these things, you can make a difference. So thank you very much.
Those were the words of Mr. Rubén Contreras. Now we will introduce the director of EcoInnova, researcher and professor at the School of Architecture, Design and Urbanism of the University of Buenos Aires. She's the creator of the Center of Excellence on Innovation and Technologies, Ms. Raquel Ariza. Hello, good afternoon, everyone. It's quite a pleasure to be in this meeting today. I will tell you a little bit about, and I will show you here, what are the topics that we're going to touch up on and what we are doing with circular economy here in Córdoba, what we are taking into account, what is Córdoba doing, and some cases that we can analyze. First of all, I wanted to tell you a little bit about the challenge that the city is facing to start this Center of Excellence in articulation with the OAS, and how we are thinking on how to improve productivity, efficiency, and not only looking at this from an environmental point of view. That is, how to make the manufacturing processes more efficient. Ruben already brought you some quite great overview. And he clearly explained about the different environmental restrictions and climate change restrictions that we have. But we also keep an eye on developmental objectives and goals. Everything starts with consumption, sustainable consumption and manufacturing. And this diversity also allows us to make and think of other applications of these strategies, gender, city structure, and many other objectives. And I also brought you here this donut graphic because we are thinking also about prosperity and rethinking this distribution to recover environmental topics, but also thinking about the prosperity of the different regions and territories, because we do not only want to preserve, but also achieve a certain prosperity. And that's our challenge. The other point of view that we wanted to discuss is sustainable development from an environmental, social, and economic point of view, but thinking about it with a different relationship, trying to preserve the environment so that human beings can continue living and using the planet and the resources that we have. And from the economic point of view, to address current economic issues, which is quite easy to change only as long as we have the people willing to work there and the environment to help us. We are starting to create regulations, and we are assessing how we can implement those standards so that we can guarantee the linkage between companies, business-to-business relationships, and guarantee certain regulations that can limitate and order all these initiatives. The other pillar of this Center of Innovation and Technology is focused on the technology and thinking also about the habilitating technology, the transformative technologies, which is the center ring that we have in this graphic. And what we are seeing more now is applications, meaning what are we going to use that for? And that's what we are working with the other centers of excellence. And there are some technologies that we are adding to our projects. And what I really wanted to show you is that the second ring, which is what we are doing this for, where are we using this, is how to use this technology, this applied technology, considering all the time the human factor and thinking always about the people. The technology shouldn't complicate our lives, but rather make it simpler. The same thing that we were thinking about renewable energies. We managed to solve something, but at the end of the day, we didn't think about it in a correct way. And here we also need to rethink business models, thinking about how to change our mindset. Not everything and not all benefits need to be as tangible. We can think about services and think about all of this in a more systemic way, addressing its complexity and all of its factors. And we also have this interconnected society that should be connected for useful things. We have social media and technology, but this connectivity should be aimed to improve collective work to solve these problems that all of citizens have. And all of these technologies shall be regulated as well. And then when we speak about innovation, it's not only technological innovation, but in organizations, in services, brand. And just look at innovation in a broader way. This is for you to understand what is our point of view and how we are addressing this. The thing is, we need to shift the model. Shift from a linear economy model to a circular model where we start seeing different actions that we can take to actually avoid resources going to the landfill. And in a very similar way, as Ruben told you before, we need to think about this in two different cycles. How to manage the cycle of materials and then also rethink how we make decisions about them. Circular economy faces with a systemic change, design, and also the actions that I'm going to take after the lifespan of the product ends. And then also to exemplify traditional models, when we were designing a product, the product was then manufactured in great volumes to have a lot of stock, because as we just saw, everything started evolving, and it has been a process that has been increasing the way we produce and we manufacture. It was not always the same way. And when I start digitizing technology, the relationship between the commerce, the store, and the user allows me to work with alternative technologies, design something and only produce it when I need it, or manufacture when I need it. And when we think about this in a value chain logic, we can think about the raw materials, the different components, industries. We have then the commercialization until the product reaches the users. And if I have the traceability of all this use of the material, we can find new solutions that we had before in the linear chain. And also think about what happens when the product reaches the user and what the user does with it. Think about this reusing, have a same product be used many times, repair it, and this also allows for the creation of different businesses, new opportunities. We could also think about these materials going back to some other part of the previous cycle, but that requires that the product is designed so that we can actually reuse the raw materials firstly used. We are kind of just like enemies of composed materials or of mixed materials because they cannot be separated. And then we have other issues that are strictly related to the user, and then we finally have the clean spot, the clean site for the product. But all of these opportunities need to be created. They are not ready yet. Now we are working in the last line, the blue line that you see at the back, recycling a product and bringing it back to the circuit, to the cycle. But if we look at the bottom, this line that speaks about what happens before the product is consumed by the user, we will see that it requires a lot of perfecting and improving the process and the cycle itself. And we can also use artificial intelligence not only for costs, but also to improve the traceability of the data on the materials used. And then what Ruben also mentioned is starting with corrective actions, which is what we are doing now, because it's the first problem that we have at hand. The waste that is accumulating and that could have some value, but these are corrections to the linear system. But we think that it's okay to address that line, but it's actually what we need now is to go and to start creating in a circular economy system. To start working with something and see how we can solve it. For example, in the pandemic, we were thinking about the automotive industry and thinking about how to improve the way things are transported. And then when we started using Zoom, then that replaced all the use of the transport industry, and provided us with a lot of options. And then at the top, what we actually would want to have is to start working with predictive actions, with a forecast of what is going to happen. But for that, we need data that tells us how this is used and what will happen with that resource in a couple of years. And then that will help us reach and create systems when we can have zero residue, which is feasible now only by sending our residues somewhere else. Say, for example, I send it to China and have them resolve it somehow. But actually, the idea would be not to generate all that waste. And that's our final goal. And now to tell you a little bit about what we are doing in Córdoba, you will see there are many actors and stakeholders involved, because a systemic approach, a systemic change, and a paradigm shift, it's only feasible if we have many stakeholders and actors involved in it. And we have collaborated for this with the private sectors in workshops, making auctions to add value to the material recovered. This is created not only for companies or cooperatives or consumers. We all need to take part of the shift. Córdoba has already been working in this for many years. That's why we are here today in this space. We have also worked a lot with knowledge, training, making people aware. That's why we had the summit. We have a circular economy degree. And this is all to create an ecosystem around circular economy. The idea is also to create a lot of data so that we can establish relationships between the data and start having different information and data layers that can complement each other. And here you will see some examples that we've been working for quite a while in the Municipal Circular Economy School. We are now thinking about corrective actions, trying to recycle or to reuse in the same system the materials. But then I will also need to think about this reacquired material in a circular way, because if I manufacture a new product in the same way, then it won't be able to re-enter the circuit. And that's the great challenge today. So we are analyzing some models, starting to rethink something that is starting to be, or that will become secondary raw material again. What happens after that is consumed? You will see this in an example of urban equipment. And we were redesigning and rethinking this, because otherwise this would be a trial and error project. You can see here another case. We create products with recovered wood. And they are created while thinking about the needs that can be met with that material, but also trying to generate design and development that other companies could also use, because the wood that we have now was already disposed of by another company, and they themselves could reuse it. So we have a lot of material that the school and the degree that we are having in our school, we can think of how can it be reduced? What are the economic aspects of not reusing this material for the companies? Think about the users who will assemble the product, who will disassemble the product, who will repair it. And this requires studies from a lot of stakeholders. We can see here a diverse selection of products. And as all of these materials are generated from pre-consumption phases, we can see how it is reprocessed, how it becomes a secondary raw material. You will see a different case here. We have some cases related with cardboard. You already saw some plastic and wood cases, and cardboard offers the same possibility. We can also think about this material as something that can also have didactic uses, to be used in schools, to be used for crafts. And then thinking about a macro level and the value chain, if we spoke about, for example, the plastic industry and how to recycle plastic, you will find out that plastic is a whole complex world. For wood is, and the more that you mix plastic, the more it loses value. So when we need to think what will happen with PET, with polyethylene, with rubber. And if we start thinking from this very start, we need to think about what will that raw material be used for, and if that material comes from a non-renewable resource, and really think about how that product can be reused in the same circuit, in the same cycle. And also think about pre and post consumption. In the pre consumption phase, everything is together, everything is mixed. We have a couple of industries in the oil sector, and finally, we have many other companies that will end up having and be involved in the creation of plastics. And when that plastic is consumed and it enters the consumption stage of the cycle, you will also see how territories redefine the way that the logistics is affected to actually reuse that material. For instance, plastic has helped increase the lifespan of foods. But there are other materials, other plastics that could be reprocessed, that could substitute other materials such as polyester. There's even fungi that can help with this and make other materials biodegradable. And we could also have new technologies to distribute or redistribute the technology to improve the process. Say, for example, in the beer industry, we could have a customized bottle created by redistributed technology. If we think about aluminum and we mapped this industry, we couldn't even see what enters and comes out, what's the input and output of each value chain. It's quite hard to visualize. It starts somewhere and really affects the other parts of the system, and they all work in really complex and different ways. And all different organizations are involved in different processes. Some are SMEs, some are big companies, some are cooperatives. Who ends up owning the value of the material at the end? We actually need to sustain and support that value. So as long that value is maintained, and the profit of that value should also be maintained. I wanted to show you here some of the tools that we are working with and that will be shared with you later, so that you can also start creating your chains. I like to think of these tools as live tools that we can all work this to compare information, to share knowledge. You will see different instructions and guidelines of how we analyzed and created different opportunities. This was produced together with the universities. And it will be very interesting to also learn what other countries are doing in this regard. And all of this helps create synergy. For example, when speaking about metals, as we were discussing yesterday, for example, just common steel could be reduced to create other machinery, but that requires regional agreements so that it actually makes sense to reuse and renew the value of that material. And thinking about what tools to use and how to adapt them to our own logic, we saw that there was a lot of material and knowledge from Europe, but we needed to adapt it. And while trying to think about that and finding what we could use and what opportunities were there for us in that material, you will also be able to see this in our tools. And in our culture, for example, we can see the difference that we are very used to repairing and reusing products and materials. So we can think about things that we do every day in circular economy terms. Finally, I wanted to address some of the challenges that we have when thinking about circular economy. Ruben also already mentioned some of them. So to complement, I would like to speak about the material challenge, how these materials are traced, what is their lifespan, how can we actually reuse it and do not add energy to the reusing of that material. So actually to close the cycle. Then the challenge of social equity and improving quality of life. Everything when speaking about the environment and resources, we should be using all of this to improve the quality of life of the people for all the planet, creating equitable opportunities. Then the challenges of value proposals, thinking about the Porter value chain, which has this logic that any movement will create value, but not all, I do not think that all movement will create genuine value. Some of it has quite a high price. It has a lot of cost, but it doesn't have much benefit. So we can rethink that flow in the value chain. We could make savings in logistics. We could use technologies for that because, for example, some technology allows us to send something through email instead of using paper mail, because it creates value and it's not creating a transport cost and a carbon footprint. And finally, how to build a sustainable ecosystem. For this, the organizations that are involved in this, in the formal and informal system, for example, cooperatives that help us have some social responsibility in the recovery of resources. But it's not only a single characteristic that we are implementing because we are good people. It's something that should be think about in a systemic way, in a sustainable way. And it should be implemented inside out, at the very core of the system, and to make it truly work for everyone, to make it transferable, and really create logics that can be applied in different places. Thank you very much.
Ecoinnova from the University of Buenos Aires, researcher of the Center of Excellence of Transformative Technologies from Córdoba. We'll now have a coffee break, and then we'll resume. Thank you.
guía del Departamento de Desarrollo Económico, CEDI, la señora Arián Quintal.
This session is the final session of the different contributions made by the Centers of Excellence. In this network, since yesterday, we have now 5 centers, one in Hidalgo, Mexico, on blockchain, the other center on robotics and artificial intelligence in Colombia, the other center in Chile, in artificial intelligence, another center devoted to the development and research of new materials and nanomaterials in the University of Peru. And since yesterday, the Center of Excellence from Córdoba. I'd like to highlight some of the key ideas that came along in these 2-day sessions. First of all, the intent of this network of excellence is to use science, data, and research to provide solutions and inputs to governments for decision making in order to face real problems in the communities of the Americas. So we don't want to have knowledge at the paper stage. We want it to become a useful product for society as a whole. So application of transformative technologies to address regional challenges is key. Regarding circular economy, we all agree that advanced technologies play a key role in fostering circular economy, particularly in providing solutions for resource optimization and production processes, traceability of materials since production until the end of their life, and finally, waste reduction. Some examples that were mentioned are the use of artificial intelligence to analyze data in real time and optimize resources such as water, energy, not only in the households, but also in the agribusiness sector. Likewise, we listened to some good practices from the Center of Chile on an initiative to reduce the use of insecticides, chemical and fertilizers, in order to prevent contamination and the destruction of habitats, for example. New materials account for another new way where circular principles can drive sustainability. The development of biological materials and biodegradable materials derived from renewable resources is a good example. These materials provide alternatives, feasible alternatives compared to traditional plastics and make a transition to a different kind of economy. Blockchain technologies, on the other hand, arise as a transparency and traceability factor through different blockchain platforms. The stakeholders, universities, governments, the private sector can trace their products from raw materials to recycling at the end of their life. Later on, we'll listen to the application of this model from the Center of Excellence from Hidalgo, Mexico. Finally, we believe that convergence between robotics and artificial intelligence provides an opportunity to improve products, which is also a key component for circular economy. In summary, we have a lot of opportunities of transformative technologies from the centers that allow us to foster circular economy and face climate change challenges in a collaborative way. With this, I'd like to give the floor to the experts. The OAS is committed to continue working with each of the centers of excellence in order to to provide the benefits of these centers to the community. Please feel free to join us in building a new, more equitable and more circular future in the region. Thank you very much. Thank you, Ariane Quintal, who's the expert in science and technology from the Department of Economic Development, SETI. We'll now listen to the presentations of the Centers of Excellence. Let's welcome the Director of the Department of Physical Engineering, University of Engineering, the Center for the Development of Advanced Materials and Nanotechnology, Maria Quintana. Good afternoon. It is an honor to be back with you today. Delighted to have been able to visit the city, to interact with the heads of the centers of innovation, of excellence. I love what you've been able to develop in terms of circular economy. We were taken to the schools where they're doing this incredible work with waste. Unfortunately, my country wouldn't have such a structure, and I believe I'm taking a lot of knowledge with me back home. So, and we'll have, I'm sure, future collaboration with Córdoba. What we do in our Center of Nanotechnology and Advanced Materials at the university, the National University of Engineering, I'd like to refer to the projects that researchers are developing at the center. Yesterday, I talked about this two-story building where we have the labs, the researchers, physicians, physical scientists, and mathematicians, where they study advanced materials. Some of these materials have direct applications. You know, whenever there's science, it's always essential to have applications. You know, oftentimes they develop a material to assess them, but maybe they don't focus much on applications. But there are research studies that are being carried out that can be applied, so we could see how we can interact with these, what we do. On this slide, we can see what we do at CEMAT. We work with solar cells, luminic devices, antibacterial fabrics using copper nanoparticles so that the fabrics are bactericidal. So different matrices have been developed. So for example, if a person has TB, tuberculosis, then with the with the type of coughing, so a diagnosis could be made. So this is being developed by a researcher and biomedical. Then in the fields of sensors, we can measure or identify moisture, humidity, pH. That is, we develop sensors with the nanomaterials we have. They're experts on corrosors, solar cells that are based on nanomaterials that use natural dyes from Peru that can degrade. So these cells are more friendly compared to the cells we find in the market. We also use nanoparticles for for water treatment. We use photocatalysis and also electrochemical processes, nanocatalyzers. And some other materials, we want to improve their mechanical properties. Then material synthesis. There are chemical methods. We have specific equipment to physical equipment and devices. We have spattering equipment, which is a physical technique that is used to develop thin layers, evaporation, mechanical milling. With a mill, we can manufacture nanoparticles. For example, producing small salts with to manufacture explosives, and then we have chemical evaporation position. And some of these materials have magnetic characteristics that we're also working on. And these are some of my colleagues. I asked them to send me some summaries of what they're doing, so that you can see the potential we have with our teams at SEMAT. For example, Dr. Jose Solis, who studies photovoltaic cells, perovskites, and thermal and bioclimatic buildings. This is his team. As I said before, textiles. They have developed some projects with some companies, and then other developments with nanomaterials to determine optical characteristics or magnetic characteristics. These are some of the projects. These are CM images, textile with a zinc oxide particles. And then the quantum dots. I don't know if you've heard about it. This is kind of pretty much fashion. For example, in TVs, if they have quantum dots, and it'll be manufacturing these quantum dots just to determine the characteristics they have, because the quantum dots, they have a size that is smaller than a nano. I don't want to be very technical, but then, the nanoparticles make an impact on the images. And then BIVO, these nanoparticles we just study the characterization of the physical chemical properties. Another research team on applied electrochemistry, such as here Dr. De La Rosa and Dr. Baena, they study this field, and they've been able to develop materials such as iron oxide for remediation to decontaminate arsenic water. These projects were carried out at a lab level and have been very successful. And right now, this research team has been awarded with, they have a PhD program, and their focus is on circular economy, one of the fields they will work on. So probably here you could have some interaction with this team. These are some photos that show what they have been able to develop. For example, fuel cells and treatment in order to through fuel cells they can use microbes and this has very good results with the electrochemical methods. We've interacted with them a lot, and they've been able to develop a sensor to detect the chemical composition. Dr. Karim Paukar is in charge of corrosion, and with her research team, they're developing lithium batteries. And then Dr. Ana Valderrama in the biopolymers research team. And this is the organic. This is my team. I said I was involved in solar cells with dyes and nanoparticles. So these materials, I use them to decontaminate water and trying to build or develop iron nanoparticles, which is related to biogas. We have this at a pilot scale, and we can take it to a larger scale, and that would be great. Materials to decontaminate water. I mean, we were able to went to the Junin Lake, the second largest lake in Peru, that has lead contamination. So we use a graphene-based material, and we use this system that ran on solar energy. It's about 4,500 meters above sea level. These are my students. So results were great, and this research study was acknowledged by different mining companies. This is an area which there are mining effluents. It's northeast area of the lake and the southeast area. You know, there are flamingos and birds. You know, which is quite. It's a big contrast when you move to the northern area of the lake. This is the biogas development. These are the small cells that, I mean, we use different natural biodegradable dyes. And Dr. Juan Rodriguez also uses titanium oxide and zinc oxide at a nanoparticle level for decontamination purposes. These cells are put in a platform and then they are used to decontaminate water. He has developed different projects and patents, and all based on nanomaterials. Titanium and oxide nanoparticles improve the efficiency in order to decontaminate water. And a lot of his projects were carried out in rural areas by using these different tubes. And so water runs through these zinc tubes via solar light, so decontamination. And he uses solar panels to run the power, I mean, for the pump to run the system. I just picked some of the things because there are many things that my colleagues are working on, but due to time constraints, I just picked up a few of the things that they were doing. This was Maria Quintana. We'll now welcome the director of the Center of Excellence in Artificial Intelligence and Robotics from Audacia, University of Simón Bolívar, Mr. Hernando Villarreal.
Good afternoon, everyone. I would like to start by congratulating this whole ecosystem operating in Córdoba because of their two huge interaction achievements around circular economy. I think they are a great reference at the Latin American level, with a lot of efforts made at international level with the state, universities, and the civil society in general. What I would like to say to everyone, all the inhabitants of the city and the province, is to own this project, to make it your own, and create impact, mainly because of all the circumstances that we are dealing with in our planet. In our center, I would like to tell you a little bit about some projects, because they are projects where we see some potential for cooperation in circular economy matters. These are our facilities, and you will see there's some infrastructure. If you see the bottom right image, you will see a FAT lab, which is a fast prototyping lab, where we are building the capacity which is available for the whole Center of Excellence. And we use this capacity based around some of the sublines we already discussed, which is eco-design. We have 3D printing capacity and a lot of methodology and acquired experience that we can share to create prototypes in a very short time. We also have remote servers and a lot of processing capacity that we can make available to everyone and for anything related with this, and for the application of AI and advanced technologies. These are some of the achievements we already commented and discussed yesterday. And it's important to highlight that some of the patents that are being assessed, because patents are first admitted, then they go through a form assessment, and finally to a content assessment. And this is the process where all the development is evaluated. So we are evaluating now how the natural resources are in relationship with the manufacturing process to be held. The important thing that I wanted to highlight here are our different lines of research: automatic learning, computing vision, natural language processing, intelligent robotics, AI, which I think we all agree is very important to work on and to regulate. AI safety and security, data safety. And for example, this is another project where I think there's some potential to collaborate with this Center of Excellence, because what we did here is to review information from different sources. In this case, it was applied to citizenship and security. And what we did is to analyze the data, not only the scalable part, but also taking into account the data where the place where this data is generated. What we can do here, for instance, is to create pictures. In this case, we were discussing safety and security. And we can create different focus items for the data. For example, I could focus on the police department, schools, or where do I have different youth centers. And we could also then correlate what is going on and the social actions of the governments in that territory. So if we extrapolate this to the Center of Excellence in artificial intelligence and about circular economy, what we can do is to detect in the space the residue and the waste collection network. We can see when temporary storing is needed, and we can have an impact on the logistic chain and improve the logistic chain and general operative aspects of it. This is where I see a great potential of collaboration. Another project is an oil detector that can also be used to separate materials. This is a solution that we have developed and has been specifically aimed for a particular subject, but we can modify some parameters and use it, for example, to separate materials, and this can be very useful for this particular center of excellence. Something I would also like to highlight is a sea robot, which is used to monitor our coral reef in the Caribbean Sea, in the coast of Nicaragua, which is called the San Andres Reef. This drone could only use and be submerged only up to 25 meters of depth. And now we are using it in 400 and 500 meters of depth. This allows us to do two important things. From the research point of view, we can take a lot more samples of the sea materials, the algae, and other materials, and we can also use it as a tool where we can adapt other devices and make a monitoring more sustained or have a better use of that monitoring to better evaluate the reef, see what is its deterioration level, analyze the level of plastics in the sea. And why is all of this plastic in our sea? It's actually because we have a production process that leaves all of this material or disposes of this material in the wrong way. And this is another way that we can show how we can really make a shift towards a more circular system. We have a lot more projects that could have also an impact in circular economy. But due to time's constraints, I would like to leave you here. And I would really like to come back and remind you that technology and circular economy can really create together a more sustainable way. Thank you very much. Thank you very much for the presentation of Mr. Eric Orozco Acosta, Senior Researcher of the Center of Excellence in Artificial Intelligence and Robotics, Audacia of the University Simón Bolívar in Colombia. Now we will have the Director of Talent of SITNOVA, the Center of Excellence in Blockchain Hidalgo, from Mexico, Mr. Hernán Islas Vázquez.
Good afternoon, everyone. I'd like to discuss blockchain and circular economy, taking a look at some of the concepts that were addressed before. Circular economy
Bueno, ya se escucha. Ya.
We have good sound now. Thank you very much. Now, revisiting what we were discussing before, I would like to give you some context on what my colleagues spoke before about linear economy, which is the traditional economy that we've been working since the beginnings of modern society, and it is basically based on the extraction of natural resources, good manufacturing, consumption, and dispose of waste. So it's taking, using, and disposing of things. So thinking about using, which is a very important part of the linear model, I think that in circular economy, this could have an economic and environmental aspect which could help minimize the use of natural resources. This is through reusing, reducing products, recycling, repairing, regenerating new materials. I think that my colleagues have previously mentioned a lot about this subject, and this is why I wanted to focus on the use, because we do not want to make these products waste. We are continuously working on how to better use products. The idea is that the final product is constantly involved in some part of the cycle. The main principles of circular economy is to design for circularity, which is based on incorporating new materials, reusing raw materials. We previously discussed that when we manufacture something, we already need to be thinking on how this product will be disposed of in the future, that the products include should not be just disposed but reused. This is a problem that composed or composites materials need to be addressed because they make the separation of materials quite difficult. Then reuse and repairing, where the idea is to extend the lifespan of products. For this, renting, second-hand products, and product repairing comes in very handy. Basically, it's avoiding consumerism and damaging practices. Then when we speak about recycling and recovering materials, the idea is to reuse materials to create new products, not only the common recycling products that we already are using, such as plastic, cardboard, and metals, but we could also analyze other types of materials that can be recycled or other uses that we can have for the same type of material. This is something that I have already observed here in Córdoba, that I have witnessed. And I think we are learning a lot about Córdoba rather than Córdoba learning from us about circular economy. I think Argentina is one of the Latin American countries that it's really betting on the environment, on preserving the environment. And as I was saying before, we all recycle, but I think this is done in a lesser scale in other countries. And it is very important to see that we can have materials recovered for electronics. We can also have different uses for silver and gold. We also discussed before how earth and soil was recovered, and this implies that we can stop extracting these materials from mines, and we can actually maximize the use of these natural resources with this new kind of thinking. Then also the efficient use of resources, which has to do with maximizing the use of natural resources, minimizing extraction of raw materials, and reducing the generation of waste. Circular economy aims and intends to create a production and consumption system that can generate more sustainable and resilient models and then help reduce our environmental impact. What would be the role or the end of using blockchain in circular economy? That's what I wanted to really discuss with you now. And the main use would be to find how to minimize waste and then also maximize the use of natural resources. Now, what would be the possible applications of blockchain in circular economy? One of them would be traceability and transparency in the supply chain. We can have a complete visibility or mapping of the supply chain from the production, the distribution, and consumption of products. We can trace the origin of materials, and then this would help really guarantee the sustainable practices. Another use is the certification of the authenticity of some products. This is where we can use smart agreements and contracts to verify the authenticity and quality of products. This is really used a lot in products brand products or products that are from luxury brands. That is when we have a lot of counterfeit products that are reproducing other designs, and this creates this kind of issue, and we could certify the authenticity of products and avoid the generation of so much waste. And then also improving and fostering second-hand markets and sharing economy. We could use blockchain to create platforms which facilitate the purchase of second-hand products in a safer and more transparent way. In Mexico, we are working with some platforms where people would place or post their products, garments, shoes, and they post this at a very affordable price. So anyone that wants to use that can very easily buy it. Other important application is digital tokens. The idea is to create tokens to represent the ownership and value of recyclable or used products, and then exchange them for discounts or free products. This would help companies strengthen and help also companies generate these circular economy projects. They could use these tokens for different research projects, just as we did with recycling. Another very important aspect is waste management, where we could really apply blockchain, doing a follow-up or a surveillance of the waste chain, and see at all times in what part of the chain the product, or which part of the chain the product is going through. So we could see where is it sourced, where is it sold, and then where it is going to be disposed of. This is something that is already done with plastic bottles. We can do this monitoring, this follow-up, and then seeing how these products end up in landfills, or when these products are disposed of in incorrect ways. We can see illegal landfills, we see waste in the streets, and this could really create projects and proposals to better use these products. And then everything related to sustainable financing and funding. We could use these tokens to finance and fund products related to circular economy, such as research, technology development, or developing technologies for innovative recycling methods. What are the benefits of integrating blockchain in circular economy? As we mentioned previously, we can create transparency and traceability of the products. We could also evaluate and assess the chain and the cycle of the product. We could guarantee the authenticity and quality of products, optimize waste management, and through incentives for recycling or reusing, we could use tokens. And finally, improve the efficiency of the supply chain and fostering innovation and collaboration. This is something that blockchain makes very easy for different governmental groups to collaborate with the private sector. This is also something that could be very helpful for social sectors to create collaboration. And all of this with the aim of improving transparency and efficiency. This is all to generate both environmental and economic benefits. As I was mentioning before, companies do not bet on this kind of technology very often. They tend to be companies tend to be a little bit reluctant because these policies are not very popular or are not well applied in the system. So we also need to consider the challenges and some important concerns of the use of blockchain in circular economy. One of them could be the lack of understanding and knowledge, the applications of this knowledge in circular economy. This is because if we do not know how the blockchain can be used, it would be very hard to apply in circular economy. So we could create trainings, talks, presentations for the population, for companies, for schools, speaking about this technology and the benefits it can bring. Another very important aspect that is also a challenge is the cost and complexity, which can make it difficult to acquire blockchain technology, develop customized solutions, and because training personnel can require a lot of investment and time and resources. Currently, there are very few centers that actually apply blockchain or that can train on blockchain. So training staff or training the people is very costly. Companies also and always tend to see first the economical aspect of things, and it's something that in the short term will be very hard to make visible for them. Another aspect is interoperativity and standards, where we see that the lack of standards and common protocols can make it difficult to improve interoperativity between different systems of blockchain and the integration with existing circular economy systems. Some systems are not compatible with others, and this creates a sort of disruption in these systems when they are not compatible or when one system does not support another. And finally, privacy and data security. In this regard, something that is very concerning for companies and also governments is that there's a lot of confidential data managed in blockchain or processed by the blockchain. And the thing is that data could end up being published or disclosed to the public. But actually, this data is quite safe. Unlike popular opinion, the data is very safe, and if there's a system where we can interact both with governments, with the private sector, and with the education or the academic sector, we could really include best practices in this type of projects. It's not that any other company or any other user could access to our blockchain or to the data shared. So sensitive information is always protected. What are the challenges and considerations of blockchain in circular economy in our own Center of Excellence on blockchain? In Hidalgo, Mexico, some of the circular economy policies are related to recycling, some regulations and sanitary regulations for waste management. And that is the aspect where we are having a lot of struggles. We are trying to regulate this kind of technology. And this is now being dealt with other companies. For example, with Grupo Modelo, together with the University of the State of Hidalgo, we are working in projects to manage the beer industry waste, because once the raw material is processed, it is disposed of, and what the university is doing is to reuse that waste to make protein bars and give new use to that industry waste, because it can be food for other people. And then, of course, it would be disposed of, but we are also conducting some discussions to continue this collaboration, to do the monitoring of the residues and waste of the company and what is being done with it. Then we also have some collaborations with a polytechnical institution, which is the biggest in the country. We also collaborate with UNAM, and we are mainly working with the National Blockchain Project. We have a course with the Polytechnical Institution and the Technological Council, which we belong to. And we are preparing and training people in the use of blockchain. And the aim is to have qualified staff in the use of blockchain. And as you can see right here on screen, this is possible through the collaboration of every sector, the private sector, government, education, this is what can really help improve our initiatives in circular economy. And then to make a final remark on the blockchain in circular economy, I think this is a collaboration, a close collaboration between companies, governments, organizations, and the community. And it's very important to work together to overcome these barriers and really harness the benefits of circular economy. Thank you very much. These were the words of Hernán Islas Vázquez from Mexico. Now we are introducing the coordinator of the Latin American Index on AI in Chile, Ms. Cristina Flores.
Thank you very much. Thank you to the participants that have been here listening to these presentations. Let me tell you a bit what we do at CENIA and some opportunities we have in collaboration with other centers. First of all, CENIA, which is the National Center of Artificial Intelligence, was born out of the academia. There are 4 founding universities that put together a project, but these are now the universities that are part of the center. What makes it very unique in terms of research, these are the 5 lines of research: vision and language, neurosymbolic, artificial intelligence. Recently, we had a international meeting on neuroscience and artificial intelligence. Then artificial intelligence inspired on the brain, and then automatic learning, and then IA based or centered in the human being. So here we study different issues related to artificial intelligence, but the center itself is a very thorough ecosystem comprised of 4 parts. Research is the main area, but then there's also a technological transfer area and then linkage area with my activity. The technological transfer area is currently working on 3 areas. Service and language. We are working a lot on the development of virtual assistants, to interact with customers. Oftentimes, artificial intelligence, and our director says this, Mr. Duran, it sounds like rocket science, but bottom line, we always, supporting data processing, and one of the main areas is this one. And then I'll show you some more information about this project, how to develop assistants that can respond in using the local language to take advantage of data processing. This is the services related to vision. And these are some specific examples. For example, monitoring and warnings via safety cameras so that citizens can relate to this. And then, for example, weed detection and then for the use of fertilizers in crops. Visual inspection and quality control. This is a production line. And here, the detection and classification of objects, traffic incidents, and so on. Another important thing in terms of technological transfer is related to optimization. These are different challenges from different industries where we can use different strategies. For example, time prediction, client segmentation, and synthetic data creation via models. If you look at this, this overview, we can already begin linking some of the things that are being done here in Córdoba as a center. We have some things that are aligned with sustainability, but it's really interesting to think in, to develop common projects and apply this to the needs here, the local needs in Cordoba. Some success stories. This is in the field of transportation. This is a solution that was implemented in transit and transportation. So you see the number of cameras, the types of surveillance. And at some point, we said it today in the meeting, how we can apply these kind of technologies and data processing to waste. For example, via satellite imaging, how waste is being accumulated in a particular spot and then make the right decisions and so on. This is a language solution. Chile Atiende is it's a platform, and for a user to obtain information is really lengthy because there are many organizations and many websites. With this chatbot, we made it more, we simplified the search, and we use a more familiar type of language. Language is a very important area that can be considered for educational processes. That is, when a society wants to make a paradigm shift, that has to be done with citizens. How to be done? Then language can provide some tips. This is another example. Language Go Plicit. This is purchase and selling process. This is a lubricant company. In this case, we developed a virtual assistant for a specific lubricant customer that could be applied to the chain of players that will interact in the Center of Excellence of Córdoba. That is how to become more efficient. These kind of situations in relation to a customer chain. Telecommunications and georeferencing. This morning I talked about this example when we had the meeting, how we can, via data, how we can complete some georeferencing spaces and use this for a public good. That is, to complete the data, to provide this to touristic services, to identify population movements, and then apply some resources, communication, big data, optimization and big data, distribution chain. I mean, how to make these processes more efficient. And this is connected with the needs that will come up, during the first year of the center. That is the mapping that needs to be done, data processing, and so on. Finally, weed integrated management. This was developed by one of the researchers, Gonzalo Augusto. You can see what he's doing. That this is a very specific mapping and identification to control weeds, to manage weeds more precisely. For example, this is smart crop monitoring with using visual technology, satellite imaging, labeling, to then process the images. If you see here, selecting a polygon, a segment, and from there to move on to identify based on the crop type and the different regions to be more to use herbicides and fertilizers in a more environmental friendly way. So they're very specific uses that can be made available to general citizens. To conclude, today we have a mission. We've been working for 2 years. I mean, we've been able to establish the team and the group, but oftentimes we're not aware of the extent of these meetings. So maybe in 5 or 10 years, this may have, may progress in a way that we had not envisioned. So the citizens should be open to be in communication, to be in touch with us, in order for us to make this evolve. Thank you, Cristina Flores from Chile. We will now welcome Executive Secretary Kim Osborne for some final remarks. Thank you. This is the end of the day. It's really sad for me because I have to leave Córdoba. Would like to thank Córdoba for welcoming us and for sharing and for hosting this meeting. We appreciate their superb and priceless hospitality of these 2 or 3 days. Oh, I almost forgot how many days. Parece más tiempo. And we are really inspired by your progress in circular economy. I have to say that there's so much power, so much energy, efforts, and it's a pleasure for me. I usually have a lot of energy, and I like to work and to see the same kind of energy of our counterparts. So it's really a pleasure for me. Special thanks to the whole team of the Secretariat of Environment of Circular Economy. Mr. Filoni, thank you very much for your support in these 2 days. Her secretary, Julieta Colombres, and Juan Chapero. Tienes que venir a Washington, Juan. Alfredo Galeano, thank you very much. And Raquel, thank you. High officials, Mr. Pasarine, the mayor, and the Minister of Economy, Guillermo, a close friend of ours, and Governor Martin Charora. Thank you. Thank you from the bottom of my heart, and thank you on behalf of my team. Nada de esto es posible sin mi equipo de la OEA. I have the honor to have a wonderful team that is involved in our work in the hemispheres. Cesar Parga, who's the leader of our section of competitiveness and science and technology. He's always work, Mrs. Quintal, who works together with Cesar, and Ruben, who's an expert from Chile, who have been with us, who support us with the Sustainable Development Department. That is, we have a very big secretariat, of integral development, which is really complex. I mean, what we do, we need to continuously work, and So it's always continuous work. And so having a team like this, education, human development, tourism, culture, and SMEs, competitiveness, water, renewable energies. It is a very involved team in the development of the region. So thank you. And all of these centers of excellence from Peru, Mexico, Chile, Colombia, thank you. Thank you very much for supporting us. Thank you. Enjoy your weekend. A pleasure having Executive Secretary for Integral Development from the Organization of American States, Kim Osborne. We have shared experiences from these centers of excellence. We are now concluding this meeting. We'll now welcome Secretary of Environment, Sustainable Environment, Mr. Filoni, from the Municipality of Córdoba. It is hard to say what is being felt, even though Spanish is my mother tongue, but it's a sort of contradiction, because on the one hand, we feel deeply satisfied of having this opportunity, this experiencing of hosting the High Commission from the OAS that is characterized by the kindness and, the sadness, because this is coming to an end. It's been 3 days now where we've been able to share professional experiences we've had. We shared the experiences from the other countries in the Americas, and we had the chance also to meet and to get to know ourselves. Even though we met in these rooms, we moved from the hotel to the restaurant and to the town hall, where we just shared, personal experiences and family life. So it's really great what we have received from the OAS. It's a turning point in terms of circular economy in our city. There's a before and after type of situation being designated from the OAS is something we feel proud of, and now we're really responsible for everything we're doing. Not only myself, but all of us who are involved. I'm representing many, not only the governor, the mayor, but also, society, some sectors of society. One of the representatives, Father Mariano, and the private sector too, represented by the cluster of circular economy, different professionals such as Raquel, cooperatives, the different sectors, and different representatives. I'd like to tell them how grateful we feel. The Perspective America is, I want to have a kind of a forecast and see where we're heading. And I feel certain that in a short time, we're going to meet, we're going to have all of the centers of excellence working together on circular economy with robotics, artificial intelligence, nanotechnology, sharing this big family of the OAS, and being here, leading this process from Córdoba to the world is something that I feel grateful for and I feel proud of. And this is here to stay, as You know, Kim, you've been at the OAS for 20-some years. You know, I could probably say the same working in the Center of Excellence. You've been great companions. I think we've learned much more than what you've learned from us. I mean, we are here at home. You were able to see what we do, but I'm certain that if we go to your places, we'll be able to learn even further. Thank you, Kim, your team. Thank you on behalf of Martin and Daniel Pacerine. And even though that you could thank everyone before, I think that when things are well done and they're, you know, it's always good to acknowledge the team. We wouldn't have been able to make this possible without the team here, the local team, which is led by Juan Carlos Chapero, Alfredo, Ivana, Mariana, Eileen, Raquel. Thank you to all of them who made this possible. I mean, to have this meeting, to start writing a new important chapter of this great book on circular economy in Córdoba, Argentina. Thank you very much. This was the Secretary on Circular Economy and Environment. On behalf of the Center of Excellence on Transformative Technologies for Circular Economy of Córdoba, we would like to thank the OAS officials, the Centers of Excellence from Mexico, Colombia, Chile, and Peru, Panama, the General Councils, legislators, provincial and municipal legislators, provincial and municipal authorities, the academia, and companies and organizations related to circular economy. General participants who've also joined us via live stream. We learn, we reach further. Have a safe trip home, and we look forward to meeting soon.